Hi everyone and welcome back to Prefusion. So in this video we will solve this interesting question that one of our student sent in our WhatsApp group, right? So here we have this MOSFET circuit and they are asking us to find out the gains, the voltage gains. These are the small signal voltage signals, like everything is small signal here. They're asking us to find out the ratio of VO over VI and VS over VI, right? So how shall we go about this question, and like it can be an interview problem as well. So I will try to tackle this problem with the least amount of memorizing of formulas, right? Without memorizing any formula, how can I solve it? That will be our approach. There are other approaches, I will talk about that, but I will not do that. I will not use that because that will involve of remembering multiple formulas. I don't want that. Okay, so let's get started. So first of all, this is small signal and they have mentioned nothing about the MOSFET. So I will assume that MOSFET has lambda equal to 0, right? If MOSFET has lambda equal to 0, its own RO is infinity, but it already has a RO connected in parallel across its drain and source terminals. So it's as if that although this MOSFET has lambda 0, but it has a output impedance as if like that according to the circuit. So for the MOSFET individual, I will assume a lambda 0, but a RO is already there. Cool. Okay, that is point one. Now I have to find out these ratios. So this circuit is pretty complex, not that simple, because if this R was not there, then it would have been much simpler, right? Your VO would have been RO parallel RL. You got to solve it, right? It's uh, GMRD, something like that, minus GMRD, something like that. So, but it's not that simple. So how do I go about it? So first thing I notice that whenever these kind of things are there, I always try to simplify the whole circuit. I notice if I assume a current through here, let's say a current Ix. I know there is a loop, this current will be divided. That is certain. This current will be divided. I agree. But ultimately, what current will come out from here? It will be Ix only, right? Whatever current comes in should come out. So this is a closed network, right? Whatever, like some current will flow through here, that is fine. But whatever current is coming from the ground, right? This is coming from the ground. There is only one other path of the ground, that is this one. So obviously this this Ix current is coming from this ground, it has to flow from here, right? Current follows a closed loop. Okay, I got a very critical information. What is my VO? So current is flowing like this, so this will be plus minus. So VO is actually minus Ix into RL. And what is my Vs? Vs is Ix into R. So I got a very important relation and very simple and effective relation, that is VO by Vs equals to minus RL by R, right? Minus RL by R. This is a very important relation. Now, I was not asked to find this. I was asked to find this, right? So how do I find this? So basic thing is we have tackled one problem that if I find out any one of them, then the other one will be easily found out. But how do I go about it? So let's assume that, right? Look, there is a thing that you can assume some feedback factor and all, you can solve using that, but I will not use feedback factor. I will use basic KCL and basic concept of MOSFETs. So if I know the gate terminal has a potential of Vi and the source terminal has a potential of Vs, so what is the current that will flow through the MOSFET? Small signal current. The small signal current that will flow through my MOSFET is Gm Vi minus Vs. And through here we have already assumed a current Ix is coming in. So what shall be this current? So obviously if I apply simple KCL, this is Ix coming, this is Gm Vi minus Vs going out, so this will be Ix minus, let me reduce the font size, this current will be Ix minus Gm Vi minus Vs. Okay, so that is what this current is. Now if I know this current, do I know the drop across this? Yes, I do, right? And few more things I know. So what is the drop across this? Drop across this is VO minus VS. So I can write here VO, let me write VO minus VS. That will be equals to what? VO minus VS will be equals to this current into its resistance, that is IX minus GM VI minus VS into the resistance, that is RO. Great. I got this, but there are so many unknowns. There is this Ix unknown, there is this VO or VS. I have to convert everything into a single term. So I can convert that. What can I do is, what is my VO in terms of Vs? It is simply minus RL by R into Vs, right? This we have derived already. And what about my Ix? If this is the Ix current, this same Ix current is flowing through here. So my Ix current would be simply Vs by R, potential difference divided by the resistance. Now you might feel, sir, this is so much lengthy, sir, you're doing so much lengthy. This question is not that simple. So this will take you time. This will take you some time, right? And this can be asked in interview in the later rounds, okay? And you can do all this if you have a bit of trickery up your sleeve. So they will allow you to do all this mathematical stuff, right? Not too much mathematical, but this much they will allow you. And this can be asked in written test as well. So I'm preparing you for both written test and the interview as well. So let us replace everything in terms of Vs in the above equation. So this will become minus RL by R Vs minus Vs equals to, this will be Vs by R into Ro. This will be minus GM Ro Vi. This will be plus GM Ro Vs. Yeah, that's it. GM Ro Vs, right? GM Ro Vs. Okay. Yeah. So now I can take everything on the left hand side. If I take everything on the left hand side, what will happen? I can take few terms common. Vs I can take common over here. This will be minus minus will be simply cancelled. This will be RL plus RO divided by R plus GM RO, and this side it will be equals to GM RO VI. So Vs over Vi will be equals to GM RO divided by this. I can add, this will be R RL plus RO plus capital R. This also, so this has a, I have to make a common denominator. So this will be R into 1 plus GMRO basically, right? And this R will go at that side. So your Vs over Vi will be GMRO capital R divided by RL plus R plus this. This has an intuitive meaning. I will talk about that. Let me find out the VO over Vi. So VO over Vi will be simply, the ratio will be multiplied, this will be multiplied by minus RL by R. So this will be minus GM RO RL divided by RL plus RO plus R into 1 plus GM RO. So here a couple of things. How do I verify that my solution is correct? Whatever I have solved, that is correct. So you can assume few things, right? You can assume, what if this R was not there, this R was 0. If this R was 0, then your VO would have been simply minus GM into RL parallel with RO, right? So if you assume this to be 0, your R to be 0, this is gone, right? This is GM RO RL divided by RL plus RO. This is nothing but minus GM RL parallel with RO, right? So this we know, like whatever is the impedance connected between drain and the source, if R is 0. Okay. And similarly, you can do, if this RL is 0, what will be your VS, like that you can solve. If you do in this formula, right, if your R is 0, if your R is 0, then what will happen? Your VI and VO, if you make your R to be 0 here, your Vs over Vi will be 0. So basically your Vs will be 0. Why? Because obviously this is 0 impedance, so this is shorted to ground, so Vs should be 0. So this is how you can make intuitive sense of whatever you have derived. Right now, this took us how much time? Around 60 minutes. But because I'm explaining a lot, but in the interview this will take you 3 to 4 minutes, right? 3 to 4 minutes, and you will get 3 to 4 minutes. There is a way to solve it. Like, you're seeing this feedback factor 1 plus GMRO, there is an interesting intrinsic gain, that factor is getting multiplied. There are a lot of stuff here, but like there is a limit to which you can memorize stuff, right? You have to calculate the feedback factor, you have to do something, do that, right? Instead of that, if you just learn how to simplify this circuit in lesser unknowns and try to solve it, that will be a better approach, because that will give you a generalized approach than a specific approach, right? That's why. And there is a feedback factor, all those things are there, I'm not talking about it. If you were able to solve using feedback factor, yeah, obviously you can let me know in the comments, I'll be happy to know. Right, so this will be the solution for this question. Now, before leaving, I just want you to solve for the case that what will be my R out, right? If I am finding my output impedance from this VO node and my output impedance from this node, VS node, what will be the expression of R out? I want you to solve that and put in the comments below. So if this video helped you guys, put a like, share, subscribe, and yeah, for those of you guys who don't know, we have started our Hindi channel. So there we are solving we are studying network theory completely, which will be inclined for both gate and placement. So if you want to watch that new content, you can go over there and watch that. So thank you and happy learning.